Okay, with that, then we're going to go to Jennifer now to talk a little bit about the ASCE Hazards 7 tool. And so, Jennifer, I'll let you take it away. This kind of came out of a discussion we had about Atlas 15. I know that the Atlas program, the rainfall intensity information from Atlas, has been used in the tool in the past, but NOAA in particular, especially the Office of Weather Prediction, was very interested in learning more about the tool. And this is my opportunity to remind everybody, these presentations are being recorded. They're going to be made available. So if you're interested in rewatching or you miss a presentation in the future, we've had some discussion with the NOAA lawyers, and they say that we can make this material available, and we're setting up a web page to do that. So these presentations are going to be a little bit more accessible. Anyway, Jennifer, take it away, please.
You got it. Thanks, Dan. Just checking that you all can see that. It kind of disappears on my screen sometimes, but so Dan, I had on the agenda that we were going to 110 and then having a break, so I can get us back there. If we're doing 15 minutes, I'll watch that. But you tell me. I'll kind of follow your lead on how deep we want to go. I guess a deep of a dive on this.
Right. I would say, I'm not too worried about the break. I don't know that we've had a break yet whenever we've scheduled one. So just proceed as normal, okay, and we'll go from there.
Okay. I just wanted to be mindful of your agenda. All right. I'm going to walk us through the hazard tool, and you'll see right away this screen, and I know this might be a little small for you. I put the link in the chat if you want to play along at home with it. It's called the ASCE Hazard Tool. The 7 has been removed from the title because really we're going to more standards. So just to the point that we were just discussing, it is a goal of ASCE to have all of our standards information here on one hazards tool. And you'll see this announcement here that we just got 41, ASCE 41, which is a seismic document, into the hazard tool. So both the 2017 version and the 2023 version are now in the hazards tool. This is an ad for Amplify, which is our online platform for standards. So all of our digital versions are eventually going to have a digital online version and not just the static PDF. And we'll have that capacity to link and to show the data, and also to show errata and things like that in that platform. You can annotate it. So it's a really nice platform. And again, all these started with 7, but growing into all of our documents eventually. So this is what the hazard tool looks like. You can see down here, I think this would be of interest to some of you. These questions about where the data comes from is particularly of interest. We're going to walk through each one, but these buttons down here will give you a little more detail about where that is. So if I start here, you just put in your location. You can put in an address or a city, town. You can put it a lat long, or just pick something on the map. The tool, like lots of web tools, have a little bit of more functionality to it. You can snap to an address, or you don't have to. So when I do that with Fort Collins, this box pops up here on the left-hand side, and that you can pick on which standard you want to look at. So we have 710, 16, 22 in there right now. And again, as I just mentioned, 41, the last 2 versions are in there. So you can self-select which document you're looking at. Some of the base data is the same. In particular, for the seismic tool, it pulls from USGS the same way, just pulls the different data that they create for us. So this is the same sort of thing that we could talk to NOAA about, creating data that comes in through this hazard tool platform and then is leveraged by the standards. So I know that we have had those discussions before. So risk category ties to the risk category that's defined in the building code. We could think about it differently when we go to different documents that maybe don't have that, such as the ports and documents that Omar and Ming were just speaking to. So if I click on some risk category and soil, it's like the soil class information, and then you can cherry pick if you want to see just some hazards. But for our demonstration here, I'm going to show you every hazard. And then we're going to switch a couple locations so you can also see what it might look like. For Collins, Colorado, in the middle of the country will have different hazards than in other parts of the country. So I just want to walk through that. So once we click on that, again, it tells you your location, just to verify what that is, what the standard is that you're using, and what default values you picked for risk category and soil class. Then you can click through every single hazard. So I'm just going to walk you through this since there's folks on the call who might not be as familiar. And again, this is a free hazard tool, and we did this purposely so that building officials could use this information. It is this information that is contained within the standard of ASCE 7. That information is then populated and brought over into the building code, which is the legal requirement. And we felt that it was very important to have that information readily available for the jurisdictions right at their fingertips, so they don't have to go through the building code. They don't have to go into ASCE 7. This is right here for them all the time. So they can get the information that they're looking for. One important change in ASCE 722 is that this data lives now in the hazard tool for almost all of the environmental hazards. It used to be in 716 and earlier versions, you would open up the book and you would literally look for the map, you would look for the values. There were a handful of tools out there that could give you some digital data, but those were considered to comply with ASCE 7. In the 722 hazard, it's 722 version, it's really important to understand that the hazard information does not necessarily live in those pages. You just can't see the granularity of the data in a printed document. And so we made the decision early on last cycle, we were going to put everything onto the digital tool. And so you have to use this tool. You have to use the document in concert with the digital data. That is a really important piece of information. This is not just a deemed to comply for 722. This really is where you need to get your data. Okay, so having said that, you can see all the hazards down the side: wind, seismic, ice, snow, rain, flood, tsunami, and tornado, new in 722. If you look at other previous versions, tornado gets grayed out because we brought it in 722. So you only see the hazards that are actually applicable to the standard. So each one has a detailed sheet, and I clicked on the wind one, so it pulls up the detail sheet and it tells you we're in a special wind region. For whatever reason, it's not actually pulling the data. Boy, that's embarrassing. There should be a wind speed here. And this tells you where it comes from, some of that background, and then the source figure is listed down here. It also will do, if I get rid of this and I click on the overlay, you can see kind of a visual idea of what that map looks like. The shading in this particular instance means that's in a special wind region. Oh, that's why it didn't pop up. Special wind region. That's why it didn't pop up. But if we were over here in the yellow, it would give you a value over here for between 110 and 120, whatever it happens to do. The tool does interpolate between these lines for wind. So again, I was just going to step you through this. The seismic is a little more robust. So the wind region comes from a study that NIST has been funding through a third party. They developed that data for us. The seismic information comes from the USGS. So again, if you click on this detailed information, it will give you the design values that you need for your calculations within ASCE 7. It shows you the spectrum. And then if you come all the way down to the bottom, it'll show you here in the pop-up what the maps are based on. So again, these maps are based on ASCE 722, and it comes directly from the USGS data. It'll tell you that on each little pop-up window. You can also, again, you can go through the overlay. You guys will figure this out right away, but you see the overlay will tell you where you are in the country. And again, this just maps geographically what that data is from USGS. So you see that. Same for ice, what the ice thickness is, what the wind, again, these are the design values that you need in the standard. So those are given to you. It gives you a little bit of background and always tells you the data source, the figure that it's coming from. For snow, we have the same thing. So here's the snow map, our snow data. So there's information up here that you need to do your calculations, the data source. And then what we did for snow, because this is a new we changed the way that we did snow and brought it into boy, I'm trying not to get too technical, brought it into the same, format that we have every other hazard. And as a, we knew that the residential building code was a little bit different than the commercial building code. And so in order for those folks that building officials and designers and home builders that use that residential code, they need a different value of the snow data. So again, working with the jurisdictions and the communities who told us they wanted this, we added a value just for them into this hazard tool. So again, with the idea that this hazard tool is one-stop shopping for everybody who needs these environmental hazard loads for both the building code and the residential code for both 7, 41, and then the other documents that we eventually put in here. The goal is that this will be one-stop shopping. So we want to have all this convenient information available to the jurisdictions so they can start using this and considering this the source of where they get things. So I just wanted to point that out. This is snow. And again, each one of these has the overlay detail, which looks kind of cool. But I'm going to keep going. Rain, here's what you all are interested in. So for the rain source, we pull the NOAA weather service, and right for here, it's just pulling out of Atlas 14 for these values. Our standard uses the 15-minute rainfall intensity value, which is higher than the 60-minute, as you all know, for the roof drainage, for the rain loading on roofs and roof drainage calculations. That's what we use it for in the buildings world. So again, if you pull that overlay, you'll see the overlay that we just pulled that data directly from NOAA for 14 rather. So there it sits. And we can use that granularity. And then a nice thing about this too, again, kind of stepping through, when we get to the end, I'm going to show you these 2 summary reports, but it's really nice to see. Here's the, if I turn that rain overlay off, here's the flood detail, and it'll tell you, what kind of flood zone you're in, tell us a little bit about the jurisdiction. Now, something interesting about rain data and flood data for 7, the standard tells you how to use the data and how to do the calculations for the load. These particular hazards, rain and flood, we do not have the maps in 7, meaning we don't freeze the data and say you have to use this particular rain data or you have to use this particular flood data. For the flood and rain hazard, that's up to the local jurisdiction. So what we provide here is the national data. Of course, the local requirements trump everything. Doesn't matter what I have in here. Your local requirements are of a higher authority than what is in this national data set. So for the FEMA flood hazard, it tells you here where we're pulling from. But again, these are the national data. You'd have to look closely at your jurisdiction. Tsunami, it's going to tell you you're not in a tsunami zone, which thankfully makes sense to all of us. I'm going to show you what it looks like for Honolulu later and how you do get that tsunami information. And then for our tornado, not applicable for risk category 2. Sorry, I'd have to change this. Anyway, I change it for risk category 3. I'll show you that in the next summary. So this will give you the data for what we chose at the top. You can click on a summary. So each one of these detailed screenshots that I just showed you can appear in kind of a report format in a summary just right on the screen of all of these things that we just clicked on. And then if you want a full report for, say, your calculation package or something else that you want to have that information in like a PDF format, this report generator will show you that. And this is what it looks like. So it shows you, again, which standard you're working on, your location, what that was. I just put in Fort Collins, but if I had a particular building address, it would add that, the risk category, default site class, and then what the values were. So here's for the wind, here's the seismic, and it shows you all those spectrum like we talked earlier. And then if you keep going, it shows you the ice hazard, what those values are, the snow hazard, what those values are. the rain values and where, and everything shows the data source and where those are coming from. So again, you can download this as a PDF file, add it to your calc package if you want. And that kind of, for a structural designer, that freezes that information and says, this is the information that I'm using. This is the source where I got it, and kind of gives you something to hang your hat on, rather than say, well, taking a screenshot of a website or something like that. So that's the sample. That's the kind of demo for the middle of the country. I was thinking of going through the end of a California example where you can see a little bit of more. Actually, what's better, not Burlingame, is Monterey. Monterey, I didn't spell that right. All right, California. So if we go into a place that we know has some water issues, and then we look at some of the results, you can see it means a little bit more when you see the flood details. And if you do an overlay, it'll show you a little more details about what actually is happening in that community relative to flooding. And then here's the legend down here. And again, we just pulled these in from the FEMA maps. So that's that information. Going back to John's point, why we're working with FEMA so closely on the next generation 2.0 of the FEMA flood maps, is to be able to pull them in the format that's needed for designers to consume them. It's the same thing we're talking about with the NOAA climate data, to be able to get that information in a format and to the granularity that is needed, so we can pull it in for designers fairly easily right here. And then the last kind of spot I wanted to show you. So you saw when we looked in Colorado, when I clicked on tsunami, that it said not in a zone. So when we come back out here to Honolulu, Hawaii, let's go back. So I put in Honolulu, Hawaii, and I clicked on view results. It'll show you that for this particular location that you're not, whoops, tornado, that you're in a mapped tsunami zone. So if we zoom out with the overlay on, it'll show you these are the zones that are affected by tsunami. However, tsunami has a whole different set of data that's needed for the calculations. This was something we talked about very early on in the task force. When we first started meeting, Dan, if you remember, probably close to a year ago, NOAA is instrumental in creating this data, and we partner with NOAA, and there's a little bit of, again, getting the data into the granular format that can be consumed by engineers. That little piece, that last mile, we could sure use some help on that. So it tells you the data sources with this separate database that we use here called the tsunami database. And then if you open that, so you can click on either one of these, and it'll open it in a new page. This is really particular to the tsunami hazard. So we have a separate tool for that. It tells you some details here when it was last updated. But again, if we want to put Honolulu in here and we do a search, we can get it down a little bit more granular. And you can see the design values that actually start popping up. So if you were going to be doing a design for, still loading, looks like, if you were going to be doing a design for tsunami, you know, these data points would mean something to you. And so you could come in here and really look closely at your site. It would tell you, you know, the run up distance of the tsunami, the depth of the tsunami. It would tell you the offshore characteristics here. So how we calculate the loading from tsunami within ASCE 7. This tool gives you, again, all of the data that you would need. So we're going to pick something like a risk category 3. It's going to tell you which sections apply to the code, which ones you have to follow. And then this is a little tool if you were actually going to do your design, you would start off something like this, and you would do your little transect, add a transect, and then it gets kind of fun. You try to get it through your try to get it through your project. There's better ways than just eyeballing it, but the tool will do the calculation for you and get you some of that data that's needed. And again, all of the underlying data is identified in the notes. Where we get this from, how we do it is also identified more clearly in the standard and in the commentary. So those are the two tools that so if you do plot transect, you can see where it starts, and then when it hits your building, you know what it's going to look like at the elevation. So again, these are some tools that you need to use to do the calculations when you actually get into doing a tsunami design. So those two work together. But again, that's kind of the overview summary of the tool. I kind of just stepped through every single hazard. I stepped through different locations. So hopefully you all are playing around with it. You can see your own, you know, community, maybe a certain project that you all have been working on or something like that. So any questions, Dan? I can take it from there, or if we're
No,
not,
that
we
was
can move on.
fantastic, Jennifer. I see so much potential here. But John, I see you've got your hand up.
Thank you. Awesome, as always. Jennifer, what about the fire hazard? And,
Wildfire?
well, to the extent that ASCE 7 addresses fire,
So,
fire loads, and does
yep.
any of that translate into the hazard tool?
Yeah, it doesn't, because it's not external fire. ASCE 7 does performance-based fire design for a structural fire within a building. So it's contained within, you know, the materials that might be in that building that would cause the fire and the loading structurally internally to that building. So it's not a wildfire. And so I don't have any type of maps or anything else. In fact, there's nothing external to the building in ASCE 7 that speaks to wildfire or an external type load.
Got it. Yeah, I get that's the subject of a lot of potential research and interest in the public and private sector. Maybe someday we'll see something emerge, you know, wildfire hazard maps on a national scale. But thank you for that.
Yeah, of course. Boy, there's a lot of hands too. Let's see.
Yeah, I was going to say I've got Joe Pica.
Next. Okay. Hey, Joe.
Yeah, thanks for that. I'm just wondering on that last piece, the tsunami inundation. I'm wondering how that might even connect to the last discussion related to storm surge. So in particular, at NCI, we do digital elevation models, which is mapping offshore to inshore. And it's
Yes.
used both for tsunami models as well as for storm surge models from tropical cyclones. And I'm just wondering if the same tool might inform that compound hazard that we were talking about in the last presentation.
That's a really interesting point. I don't know that the team has talked about that combination necessarily, but I know that sea level rise is something that must be considered in the tsunami chapter. It was the first one that had that requirement actually back in the 716 version. I don't know the details of, I don't think it has that modeling or that capability in the hazard tool right here. This is just with the offshore amplitude, but I know that it has to be included in some capacity. But that's a really good point, Joe. I would be happy to learn a little bit more about that and either bring it back or, you know, have a discussion with some of those experts.
Sounds great.
Yeah, thanks.
Now I got Ben and then Omar and several others. So Ben.
Yeah, thank you, Jennifer. Very cool. I guess I had two questions. One kind of process. On the other side of ASCE 728, if I understand correctly, that the new chapter on I don't know the exact title, but
Future
the new
conditions. Yeah, future condition.
Yeah. If that chapter is voluntary, how will the numbers in that voluntary chapter appear in this tool? Like, have you thought about that?
You know, I have two answers for that. For one, because it is a voluntary chapter that's additional, all of this information will remain, right? And so if you're not interested in using that, or your client doesn't want it, or whatever, you still can go right to the base tool, and all of this information will be available for all the hazards without that consideration. So still moving in that direction. I think Dawn is on here, and I don't know if they talked about presentation yet, but there certainly would be, they have talked about, you know, doing coefficients, maybe different ways of visualizing it. I'm not quite sure, but if it made sense to put it in this sort of a tool, 100% we could put it in the tool. So if it, for example, is a coefficient on top of, say, the wind speed, that would be fairly easy to recreate that layer and say, here's what it is with that new coefficient. So depending on where the data is coming from, it could be fairly straightforward by just reproducing a different version of that same map, but identifying it very specifically and very differently. So perhaps maybe in this type of a detailed, a detailed list for your wind speeds, you have something in here that says future conditions, or maybe it's a different screen. I don't think that I have certainly not gotten that far. I don't know if the committee's thought through any visualization for it, but this would be the ideal, that we have all that information available. It could also be, Ben, that we have that information in that kind of a format for wind, but we maybe don't have it for flood. So it kind of just depends on maybe what that hazard is and the maturity of the data that's in that space, and what we think we're trying to do.
Yeah, Jennifer, and I'll pipe in.
There he is.
I'll pipe in a little bit there. Jennifer, it's absolutely correct. It hasn't been fully determined yet. Some of the chapters are talking about new maps. Some of the hazards are talking about an overlay. So maybe click on an overlay that you have there for something, you know. So it'd be similar to this, where you might pull up, if it was a regional coefficient, excuse me, regional coefficient might show up on an overlay that says, you know, for this region of the country, the factor is 1.05 or 1.1, you know, whatever the factor is that you would put on it. The other one, if we truly do have some maps that are developed, then those maps would be similar to this. There would be an overlay map, but it would also, as Jennifer said, in the details, probably cue that number and give it to you. But it would be just like you have wind, seismic, ice, snow, and all that list on the left-hand side. Down at the bottom, you would have future conditions. And you could then query under the future conditions for those different overlays or maps or factors.
Sure. Yeah. I think we could visualize it a couple of different ways.
Yep.
All right. Excellent. Omar?
Yeah, thank you. Thank you, Jennifer, for this presentation. I have a couple of things. Would like you to join, have a special meeting with my committee to go over this with them so they better understand the tools. Will be a nice topic. I'll coordinate this with you by email later on.
Yeah, I saw your chat. I didn't get a chance to answer back, but of course, we're happy to. Yeah.
Thank you. The second thing is for the tools here, can you adjust the return period for all of them? Like, let's say I want it for 50 years or for 75 or 30 years. Is this available to adjust for all the tools, the hazard tools?
I believe so. I mean, we have a lot of higher return periods. We have some that are for serviceability that are the lower ones, but then the higher ones for like tornado and things like that also appear on in fact, I think I just showed it in the detail. So you can see some of the real high returns for the tornado, and then some of the lower ones for serviceability are also included in that detail. Is that what you meant, Omar?
I mean, for the other hazard also, not just wind, right?
Yeah, where they're available, I think we've been showing them. It also depends on the risk category. I don't know what I actually have connected. Risk category 2.
Okay.
But it has the flexibility. This tool has the flexibility to be able to bring in data in a meaningful way based on standard that we're looking at and then the hazard that we're looking at. So if you can conceive of a way that we can parse that data out to be consumed by the designer or by the jurisdiction or maybe by the owner, like the Navy, then they can consume that in the way that makes sense to them relative to what they're trying to do. So it's a data tool. Like we can pull in stuff and show it differently depending on what we're trying to achieve. That it has a lot of flexibility, which is really nice.
Okay, good.
Excellent. Thank you. All right, I'm gonna, if Sihan, you, Jamie, and Allison can be fairly quick, I would appreciate it. So Sihan.
Thanks, Dan. Thanks, Jennifer. Just quick question. We know many of the states or municipalities have different local codes and they adopt different versions of ASCE. Is your plan for this hazards to give an indication or guidance in terms of which version of ASCE has been enforced for that particular region?
No, that really is not a goal of ours, Sihan. It really is up to the designer or user to know which code they're working under. Because even if their local jurisdiction has a certain code, you know, that they've adopted, some projects you could use a different one. You could go higher, you know, you could go a little bit more. So we're not planning to do that at all.
Okay.
I guess the only thing I would add, Jennifer, to that is this is not the database for ASCE 710 and ASCE 716 are still there. So if you're using if they're referencing an older standard, you can choose which one of those that you want to use. We only go back to ASCE 710.
Yeah.
Excellent. Okay, thank you. And now I've got Jamie and Allison.
Yep.
Thanks, Dan. I'll keep this brief. My question was about waves, actually. I meant to ask the question of Ming too, but I don't know exactly. So are waves inherently incorporated in the flood overlay here, in the flood report? And so if that's the case, thinking about future conditions, you know, in the context of extreme water levels where waves are actually not included necessarily, how would you kind of see waves being included for some of those future condition overlays and some of that work?
Well, thanks, Jamie. The calculations in 7, I can't speak to Ming's standard, but in 7, it's based on a depth and a velocity. So the wave impact is calculated separately for how it would affect the load of the standard. So I don't, you know, the information that we get from the maps just gives us the depth and the velocity for that. And I guess if you're in a certain zone, it tells you if you have to use, you know, the wave action, or if you're not in that zone. And I'm not the expert on the X zone and A zone and everything, but John is on here and he'll tell you which ones you have to consider depending on which zone you're in. But it's not, I don't think, John, it's not in the map.
Yeah, currently, right. But you know, the promise of the future flood risk data with a much more rich, robust, comprehensive data platform is intended to include more information about waves so that that can be used by designers and complement what's in ASCE 722, the supplement, which requires consideration of wave loads in coastal areas. So it's not here today, but you know, we can look for that, and the collaboration that occurs with OR and NOAA and FEMA on the future flood data. I think it's going to yield benefits for the hazard tool.
Yeah, oh boy, that we're really excited about that work, John. Okay.
All right, so Allison, last question.
So, presentation and great tool. I've looked at it before and it was great to get the orientation. I'd like to clarify that this is showing the information that's based on the ASCE standards, because I thought you said something in your presentation about the fact that it represents local codes. But then your response to a previous question said that no, it's up to the individual who's using it to know what the code is. If the code is based on the standard, then this is the correct information. Am I interpreting that correctly now?
Correct. This only shows the ASCE standard data. So what is required by the standard. I think maybe what tripped you up was I was trying to articulate that the data is no longer in the book, in the printed book. It's now only in the digital tool. So if you open up 722, it's going to say go to the hazard tool to get your coefficients, for
Okay.
example, like for seismic. So maybe I didn't say that clearly, but the local information will always be that will always govern every time. And so it kind of is up to that jurisdiction which standard they adopt or which project, if we want to go higher or lower, different document. So we don't have any local information or requirements in this tool. It's only the national standard.
And then everything it looks like it's based off of a GIS system. Is that correct? Like it looked like it was using Esri.
I'm sorry, you kept cutting out. Is local but it's based on?
It's not a GIS system. You're using Esri.
Yes. Yep.
Okay.
Yep.
Thank you so much.
Yep. But the data is all just pulled in so that the USGS data is just pulled directly from the web service. Like you could go there today. You could go to the USGS website and you could pull the data. It doesn't have a user interface, so you just get like a massive data file. All this does is pull in that data and shows it to you in a more meaningful way. So the data, it really just comes from the agency. We just make it look pretty on this, but the root source of the data is for seismic is USGS, for example.
Excellent.
All right, are we good?
Yeah, excellent, Jennifer. No, that was fantastic, and I just see so much potential here, especially, you answered my question right out of the gate, which is this is free. And so, I mean, that just opens up so many possibilities. And so as I already sent you an email, I'd like to kind of follow up on this, especially as we add other standards.
Yeah.
Right. I mean, it just becomes more and more and more powerful. So I think that's just fantastic. All right.
Good.
So obviously we powered right through the break. And so, Jamie, you got a question there? If the data are pulled directly from the government source, I suppose there's a risk that the data won't.
Oh, that's funny you mentioned that. We've had that discussion a lot. Yes, that is a risk.
Right. So we got to do a little QA/QC, I guess, is part of it.
Well, we don't cache all of that, but if we knew that there would be an instance, we could store it. So if we knew the government was going to shut down, we knew there was a problem, we could store it and it's just a lot. It's just a big chunk, as you would imagine. So we directly query it every single time right now.
Okay, excellent. Thank you. Yeah, I just think there's so much potential, Jennifer. I would expect maybe a follow-up discussion because I'm sure our NOAA and federal agency partners are all thinking about how they could make use of this.